Welcome to Luca and Miguel. Enjoy the video.
You start by securing the core metadata: sample ID, radiation wavelength, and scan range. This guides every subsequent choice. Once done, import the raw file into your chosen package and set detector geometry. Do not skip the zero shift correction because peak positions depend on it. Next, remove obvious spikes and subtract a basic background so peaks emerge clearly. This first pass readies the pattern for peak fitting and phase analysis, and it prevents bad initial fits later. You now focus on peaks. Detect peaks with sensible thresholds and a realistic width range, because missed peaks ruin phase identification. Then fit each peak with Gaussian, Lorentzian, or pseudo-Voigt shapes to get positions, heights, and FWHM. These parameters tell you crystallite size and strain trends. Once you have a reliable peak list, match reflections against the database to propose phases. Prioritize consistent sets of peaks and explain why a match fits, rather than accepting the top hit blindly. You finish by refining the whole pattern. Run Rietveld or full profile refinement and sequentially refine scale, lattice parameters, profile and background terms. Refine conservatively to avoid correlations. Once converged, compute weight percentages with Rietveld outputs or RIR methods and report uncertainties, document assumptions. Finally, validate by inspecting residuals and the difference curve. If peak positions shift or residuals show systematic structure, revisit calibration. Tip:
Thanks for watching and please subscribe. It's the best investment you'll ever make.